Hello everybody and welcome to the demonstration of my prototype. My name is Charlie Barton. I'll be showing you a little bit about my smart temperature control system. So what you're looking at right here is the main hub of the temperature control system. You can see the joystick, which is used to control that little servo motor which rotates the fan. You can see the fan itself, which is mounted to that little blue servo. And then you can see the microphone, which is used for the voice activation part. And just below that you can see the LEDs, which are used as indicators of the state of the system. Then coming out of the left side of the box we have the Arduino USB cable. So you can see this is plugged into the computer right here. And after a short period of time you can see the red LED go on as a sign of the off state of the fan. The little LED next to it is an RGB LED, which is actually used as an indicator of temperature, red being the hottest and blue being the coolest, and then it's scaled linearly between those temperatures. Here you can get sort of a good look at how it changes slightly. I have it set to change a little bit more drastically just because the temperature doesn't vary a lot in the lab. This is a little demonstration, a couple clips of demonstrations actually, of how the motor works with the joystick. When the microphone hears a loud noise, the system will turn on, the DC motor will start rotating with the fan, and then the joystick is able to control the servo, which moves the fan back and forth to the user's needs. Unfortunately, I wasn't able to film this video with live audio. The microphone's extremely touchy, so even a little bit of volume just from my voice will set it off and disrupt the system. Here you can get a little bit of the look inside. You can see my breadboard with all sorts of wired components. You can see the 9-volt battery there, which is used in tandem with the DC motor. And then back there you can make out the Arduino a little bit and the Arduino cable, which runs out of the left side of the box. All of this was put together just based on schematics, whether it be from Jeremy Blum's textbook or from other tutorials I've found online. For example, Adafruit has a lot of extremely useful videos. You can see how the LEDs are all put up right against the box so that they can just be seen from that little slit in the box, and then no other wiring is needed. The other three components were soldered to extension wires and then fixed to the top of the box so that they stick out nice so you can use them really easily. Then I'll just take off the top of the box a little bit so you can see inside. Here you can get a better look at the Arduino. It's the Arduino Uno. Most of my components are wired to the analog ports just so I can use the either the pulse width modulation or the analog read functions. And as you can see, a lot of jumper wires just to try to move around the different circuits. You can also get a good look at the soldering I did, especially on the microphone right there. There's also a little look at the capacitor and the diode used with the DC motor to prevent any electrical noise. Here's a little bit of the soldering I did on the joystick just to get that to be able to jump off the board a little bit. Makes for a lot nicer user interaction. Then you can see a little bit of the servo. I've soldered those wires to the DC motor just to get a little bit of extension. Again, just to take it off of the breadboard, give it a little bit more of a polished look. Other than the joystick, which is sort of an optional feature of the system's completely hands-free. You can just use your voice to activate the fan on and off. And the LED works as a really good indicator of temperature, which is independent of any temperature scale, whether it be Fahrenheit or Celsius. Right about here you can get a little look at the temperature sensor I've included. It's just there to the left of the joystick underneath. It's a little covered up by wires, but that's what we use to scale the LED and read the temperature. Here you can get a little look at the circuit diagram I made for the project. As you can see, it's not too terrible wiring. A lot of components just go to ground, the port, and 5 volts. As you can see, probably the most difficult component to wire was the DC motor, which wasn't even too hard. Just had to wire it in parallel with a capacitor and a diode just to make sure that there wasn't any electrical noise coming back. But overall, a pretty easy project to put together. Thank you for watching, and I hope you enjoyed the video.